Here are the notes for part 1 of Unit 2.1. We'll be looking at interior angles and polygons. We're going to start by looking at some definitions. The first definition we'll look at is the definition of a polygon itself. A polygon is simply a many-sided figure. Where the sides are line segments. That means that a polygon has straight line segments for sides. This figure, like a half circle, would be a non-example of a polygon, not a polygon, because the curved side is not a line segment. The word regular, when we talk about a regular polygon, regular means equal side lengths and equal angles. So this first one's a hexagon, and all of these side lengths would be equal. And then I'll zoom in here. All of these angles would be equal. One of the things we're going to study in this unit is how to calculate the angle measures of those angles. Here's a regular triangle. It's equilateral, meaning equal-sided, and equal angular, meaning equal angles. And then finally, here's a regular quadrilateral, which means it has equal angles, they're all 90, and equal sides. Next, the word vertex. A vertex is a corner. It could also be the intersection of two lines, or a point in space. The intersection of two lines is a point in space. So I'll label the polygon on the right in a moment after we look at some of the other definitions here. A side is a line segment. In this case, we mean the side of a polygon. A side connects two consecutive vertices. So here's a vertex and here's a vertex. A side would connect two vertices that are next to each other. A diagonal, on the other hand, is a line segment that connects two non-consecutive vertices. So if I pick two corners that are not next to each other, so I skipped one there, this would be an example of a diagonal. An interior angle is an angle measured on the inside of a polygon. An exterior angle, in order to create and measure an exterior angle, we extend one side and we're going to measure between the extended side and a side. Our next term is a straight angle. A straight angle is simply a straight line, and it measures 180 degrees. The Triangle Sum Theorem. Triangle Sum Theorem says that the sum of the measures in a triangle, of the interior angles of a triangle, is 180 degrees. Convex. A convex polygon has all of its angles less than 180 degrees. So no matter which angle I measure, these are all less than 180. A concave polygon may have an angle that is greater than 180. So let me zoom in here. So if I were to actually take a protractor and measure all the way around, or if I were to measure this angle, both of those are greater than 180, greater than a straight angle. Okay, so now that we have our vocabulary, let's take a look at what we're going to do next. Our objectives are to identify polygons, interior angles, exterior angles, vertices, sides, and diagonals. So we've now defined those words. We're going to classify polygons as convex and concave. Today we're also going to write the formula for the sum of interior angles in any polygon. We are going to find the sum of the interior angles, and finally we're going to do the reverse. If we have the sum of the interior angles, we're going to name the polygon. Oops. So let me clear this and start over. Okay. So we're going to look at some polygons that we run across all the time. We're going to count the number of sides. We're going to count how many triangles it takes to make that figure, and then we're going to find the interior angle sum. So here's an example. A triangle has 3 sides, and it's just made up of one triangle, and the sum of the interior angles of a triangle is 180 degrees. Now let's look at a quadrilateral. A quadrilateral has 4 sides, and if I put in one diagonal, I can see that I've created 2 triangles. And the interior angle sum is going to be 180 degrees times 2 because of my 2 triangles, which gives me 360 degrees as the interior angle sum. I'm going to keep going. Here's a pentagon with 5 sides. I'm going to start at one corner and draw 2 diagonals. This yields 3 triangles. And if I take 180 degrees times 3, I get 540 degrees as my interior angle sum. Next, I'm going to take a hexagon. Hexagon has 6 sides. If I pick a vertex and draw the diagonals emanating from that vertex, that's what I get. There's 4 triangles. 1, 2, 3, 4. And the interior angle sum is 180 degrees times 4, which is 720 degrees. So to generalize, here's what we notice. If we have an n-gon, which means n sides, any number of sides, so if we have n sides, the number of triangles is always n minus 2. Notice 3 minus 1, 4 minus 2, 5 minus 3, 6 minus 4. The difference is 2 in every case. And then what I'm doing is I'm taking the number of triangles, n minus 2, and multiplying by 180, and that gives me the interior angle sum. Let's investigate that just a little bit more closely. If I zoom in on a rectangle, for example, I know that the sum of angles in a rectangle is 360 degrees because I know that a rectangle has 4 right angles. So this is just another way to show it. Okay, but what I'm trying to show with the, what I'm trying to show with the triangle sum theorem is this. I can take this rectangle, I can break it up into 2 triangles, and I know that if I take these angles, A, B, and C, that's going to give me 180 degrees. And if I take these angles, D, E, and F, and sum them together, it's going to equal 180 degrees. And again, 180 and 180 gives me 360. So no matter which way I choose to solve it, I get the same result. So let's do some example problems. The first one, find the sum of interior angles of a convex nonagon. Well, a nonagon is a 9-sided figure. And the formula for the sum of interior angles is n minus 2 times 180. So that would be 9 minus 2 times 180, or 7 times 180, which is, I'm just going to my trusty calculator here, 1260. Okay, let's try another one. Number 2, find the value of x. So first of all, this is a pentagon. I can count the sides. 1, 2, 3, 4, 5. And what I just saw was that for a pentagon with 5 sides, the sum of the interior angles is 540 degrees. So I'm going to use that. I know that if I add up all of these angles, it's going to equal 540. So let's try it. I'm going to start here with x minus 5. X minus 5 plus, then I'm going to do x minus 6 plus 2x minus 7 plus x plus 2x minus 2, I've done all 5, that equals 540. Now I'm going to combine like terms. When I add these up, I have 7 x's. So I've got 7x. Now I'm going to combine the other like terms. Negative 5 and negative 6 is negative 11. It's negative 18. And then negative 20. And now I have an algebraic equation to solve. I'm going to add 20 to both sides. 7x equals 560. Divide both sides by 7. Let's see, 560 divided by 7, I'm using my calculator, is 80 degrees. Let's try question 3. Find the measure of one interior angle of a regular polygon. Now, this last picture looked regular, but it turns out that it's not, because all of these sides, be a little bit careful here, they look the same in this diagram. This one looks the same as this one, but it's not. And I know that because x is 80 degrees, 2x minus 2 would be 158 degrees, or 2 times 80 minus 2. So this picture is really not accurate. It actually looks like what number 3 should look like. Find the measure of one interior angle of a regular polygon. So we do know that for a regular polygon, for n equals 5, we know that the sum of the interior angles is going to be 540. We could look above in our chart, or we could do n minus 2, which is 3, times 180 to get 540. And now, regular means that all of the sides are the same and all of the angles are the same, which means that if each angle is x, then 5x equals 540. And if I divide 540 divided by 5, I get 108. So each one of those angles would be 108 degrees. Let's look at number 4. The sum of the interior angle measures of a convex polygon is 900. Name the polygon based on the number of sides. So this is the reverse of what we just did. We want the name. We want n. N is going to help us name it. And we have the angle sum. So we know that the sum equals n minus 2 times 180. So the sum is 900. So to solve this, I'm going to divide both sides by 180. And on the left, 900 divided by 180 is 5. And then I'll add 2 to both sides. And I'll get that n equals 7. So we can just call this a 7-gon. Number 5, find the value of x. So this is a 6-sided figure. And we know that for a 6-sided figure, if we look up above, that the sum is 720. And I actually have 5 of the 6 angles. I've got 130, this is 90, I've got 140, 150, and another 90, and then I'd like to know what this x is. So all I have to do is take 720 and subtract off 130, 90, 140, 150, and 90. So I'll get out my trusty calculator for that. And I get 120 degrees. Okay, one more. The sum of the interior angle measure of a convex polygon is 360. Name the polygon based on the number of sides. Well, I remember seeing this in the notes. 360 degrees corresponds to a 4-sided figure, which is called a quadrilateral. And that's my answer. So there it is. All right, the assignment that goes with this note section is page 364 and 365. I'd like you to do number 3, number 4, number 7, number 8, and then 13 through 20.